today's objective, scientific notation. And with the scientific notation, we're going to be performing operations with scientific numbers. So let's go over some definitions. Scientific notation, a shorthand way to write very large or very small numbers. Standard form, writing a number as we normally would see that. Okay. Vic number 1, when changing into scientific notation, if the number is greater than 1, then the exponent will be positive. Okay. Vic number 2, it's going to be the opposite of that. When changing into scientific notation, if the number is less than 1, the exponent will be negative. Vic number 3, when changing into scientific notation, you need to move the decimal to where there is only one counting number. Remember, counting number begins with 1 in front of the decimal. So let's change these into scientific notation. So here we have standard form. Okay, so they are normally, it's how we see them. So we're going to change those into scientific notation. Okay, so look at this, the number here. The decimal that we know in this normal number is sitting right here. Okay, we need to make, using our significant digits, which is 7 and 5, where do we need to put the decimal for the scientific notation? When it says in Vic number 3, one counting number. So we have to put the decimal here to where we have one counting number in front of that. Okay? So this is a large number, so we know our exponent is going to be positive. So let's figure out, if my decimal has to go here, it belongs here. Well, how many spaces is that? 1, 2, 3, 4, 5, 6, 7. Positive 7. So 7.5 times 10 to the 7th power. Same thing for number 2. Here's our significant digits. 508. All right, and again, to have one counting number, it would be 5.08. And so if I have to put it here, it belongs here. How many digits is that? And we already know that the exponent will be negative because it is a small number. 1, 2, 3, 4, 5, 6, 7. Negative 7. Okay? Now, change these particular scientific numbers into standard. Okay, so here's my significant digits. 3, 7, 9. This tells me the direction that I'm going to go. It's positive, so I know it's going to be a large number. So it's going to be this way. So it tells me I need to move the decimal, which was here. I need to move it 7 times. So 1, 2, 3, 4, 5, 6, 7. So I'm going to fill in all the places that need the zeros, the placeholders, okay? So the commas, so that's 37,900,000, okay? Now here for this number 1, my decimal's sitting there, okay? So then it says that is a negative 9 exponent. So that means I'm going to go and I'm going to move to the left to fill in. So if it belongs here in scientific form, I need to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in all of those placeholders with 0. And I should have 8 of them because this 1 is taking upon one of the place values. All right. Vic number 4. In scientific notation, you will add to the exponent when you need to move the decimal to the left. Add when you need to move the decimal to the left. And you will subtract from the exponent when you move the decimal to the right. Subtract when you move it to the right. Okay? Multiplying scientific numbers. So here I have my coefficients, and then I have my base tens. So I have 5.1 times 10 to the 7th, all being multiplied by 2 times 10 to the 2nd. So just as we've done before, we're going to be grouping our coefficients and grouping our same bases, which in scientific form, our same base will always be that 10th, because we're always in powers of 10. So my coefficients, 5.1 and 2, I'm going to group them. And then my same bases, I'm going to group them. And remember, we have multiplication, so we're going to add those exponents. And then we're just going to perform regular multiplication with those. And so when I did, I get 10.2 times 10 to the 9th. And this is where you ask yourself, when you get to this step, is it in correct scientific form? And the answer is no, because I have 2 digits in front of that decimal. And remember, Vic number 3 said we need 1 counting number. So that means I have to move the decimal to the left. And remember, I said in Vic number 4 that if you have to move it to the left, what are we going to do to the exponent? We have to add. So I moved it one place to put it in correct form. That means I have to add 1 to that decimal. And then that is my final answer. So example number 2. 2.3 times 10 to the 4th times 4.5 times 10 to the negative 5th. Same thing. Group our coefficients here. And group our same bases here. So go ahead and multiply normal. And again, we have 10.35 when we multiply that. And then I know I'm adding, but again, integers, I see a negative 5. So that gives me a negative 1. And then since I have to move it to the left one, that means I'm adding 1 here, which gives me a 0 exponent. And yes, this is incorrect scientific form. Okay? Dividing scientific numbers. Typically, you will see division with scientific numbers in a fraction form. And here, we're going to do the exact same thing we did for multiplication. We're going to group our coefficients and we're going to group our same bases. But with division, remember, you are subtracting exponents. So we have our coefficients, 7.2 divided by 4. So we're going to group those. And then my same base, 10 to the negative 5th divided by 10 to the negative 3rd. So when I divide this one, I get 1.8. And then here I have negative 5 minus negative 3. So remember, integers are taking over here. So that leaves me with a negative 2. And do I have 1 digit to the left of the decimal? Yes. So this is already in correct form. Example number 2. 1.2 times 10 to the 4th, all divided by 3 times 10 to the 8th. So when I group my coefficients, then I group my same bases, okay, powers of 10. Once I divide here, I get 0.4. We already know that that's not going to be in correct form. So we'll get to that in a second. Positive 4 minus 8, so remember, subtract your exponents. Then that gives me a negative 4. I need to make sure that this coefficient is in correct scientific form. So I must move the decimal to the right, because if I move it to the left, it's still not giving me a 1 significant digit. Okay? So I have to move it to the right. And when I have to move the decimal to the right, that means I'm subtracting from the exponent. Notice I have a minus 1 here. So negative 4 minus 1 gives me a negative 5 coefficient, or exponent, sorry. So 4.0 times 10 to the negative 5th. And that is in correct form. Adding and subtracting scientific notations. Example 1. 7.2 times 10 to the 5th plus 3.6 times 10 to the 4th. Our first step in this process for adding and subtracting scientific numbers is you must convert the smaller exponent to the larger. And if it's a negative exponent, remember that the one that's farthest away from 0 is the smallest one. So we're always going to be using our method of adding something to the exponent and then moving the decimal to the left every time, since we stick to this same process. So by doing that, since I need to change this 4 to a positive 5, I need to add 1. So that is forcing the decimal to be placed to the left, okay, 1 place, since I added 1. So that converts this coefficient to 0.316, and then I bring the first scientific number down. At this step, I see that I now have the same base 10 which goes to 10 to the 5th, and then I bring my coefficients down here. And since I am adding, I'm going to add those coefficients, and then I'm still bringing the 10 to the 5th along, and then I check here to see if my coefficient is in correct scientific form. And here, since I do have one counting number, which is big number 3, one counting number to the left of the decimal, I know I have it incorrect. If I don't, then I would use my method as far as if I need to move it to the left, I would add. If I need to move the decimal to the right, I would subtract. And so that would be my final answer. Important here, if there was a subtraction sign instead of a addition sign, you would subtract the coefficients instead of adding them. Don't forget to line up the decimals for adding and subtracting scientific numbers.